Hi, we continue with our base conversions by now learning about base 10 to base 16 and back. You would call this decimal base 10 and hexadecimal base 16 conversions. This video assumes that you have already watched the base 2 to base 10 and have read the Word document associated in this lecture notes. And if you haven't done that, go ahead and do that before you continue watching this movie. I wrote a little table of powers of 16, and the bottom row is which power of 16 it is, and then since powers of 2 are a little easier than powers of 16, I filled out 16 to the first, second, third, fourth, fifth, etc. But base 16 adds a little bit of complexity, and it's a little bit different than our usual numbers that we deal with in that, remember that for base 2, it only has the digits 0 and 1, 2 digits. Base 10 has 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, how are we going to get 16 digits for a hexadecimal? The answer is we use letters as digits. So for the number 10, we use the digit A, and B for 11, C for 12, D for 13, E for 14, and F for 15. So those are our 6 additional digits. So you would say that base 16 has digits 0 through F. So let's start with a problem, and this seems like a weird number, but B60F is a very valid base 16 number. We want to go the easy way first, and we're going to convert this base 16 number to a base 10 number. And just like any number, the digit to the right, the F, that is the least significant digit, and B is the most significant, which means F or 15 times 16 to the 0th. We're going to add those up exactly like we did for base 2. So I'm going to put the F on the bottom, then the 0, then the 6, then the B, and grab those multiples of 16 from the table above and compute all of those. And just like we did in the base 2 conversions, we're going to add all those up. So B60F base 16 is equal to 46,607 base 10. Now we're about to go the other way, the harder way, and what is important to remember is that when we did this, we did not skip any powers of 16, and the lowest significant figure had 16 to the 0th. And when we went this way, we added them all. So now we're going to go the opposite way. We're going to remember not to forget any powers of 16, and we're going to subtract. I'm just going to draw part of the table because I'm not going to have that big of an example. So this is just a partial table of the same one as I had before, the powers of 16. And let's do 1,230 base 10 and find its appropriate value for base 16. So now there's a couple things that are different for base 2 and base 16. We are going to look for the largest multiple of 16 and subtract it because we're going the opposite way. But now the complication is we have to look for the largest multiple of the largest power of 16 to subtract. Let me show you what I mean. So we look at the table and we notice that 4,096 was greater than 1,230. So we're not going to have any 16 to the third powers because that's already too big. So we ask ourselves, how many powers of 16, how many multiples of 16 squared can be subtracted from 1230? Well, 256, if we round that to 250, 5 groups of 250 would be 1250. So we know that 5 groups of 16 squared are too many. So 4 groups of 256, 4 times 16 squared is equal to 1024, which is less than 1230. So we subtract that because we're going the opposite way, and we get 206. And I put a 4 up there at the 16 squared column to indicate that that's going to be our highest place value in the base 16 number. So now our question is, how many powers of 16 to the first can be subtracted out of 206? And we estimate 10 times 16 would be 160, so 11 or 12, probably 12 is reasonable, and 12 does happen to be the answer. But instead of 12, I'm going to write C, because that is the digit that we are using to represent 12 multiples in the base 16. So that's 192, so we subtract that, and we get 14. And now we get to the easiest one of all, because 16 to the 0th power is 1. So we ask how many multiples of 1 are in 14, and of course that's 14. But we remember that we can't skip any powers of 16, so we have 16 to the 0th, to the 1st, and to the 2nd as we go up there. Instead of writing E, I wrote 14 in that second one, so let's write it E instead of 14, because that's the digit in hex. And so we have our answer. 4CE base 16 is equal to 1230 base 10. And that's it. Thank you.